26209, grounding and bonding. 3.0.0, equipment grounding. Explain how to size and select equipment grounding conductors and components. Explain how to size an equipment grounding conductor. Explain how to ground an enclosure. And there are performance tasks that your instructor will want you to do. The National Electrical Code outlines the grounding rules for most equipment that must be grounded, as shown in Figure 18. These NEC regulations apply to all installations except for special applications as indicated. The NEC also lists specific equipment that's to be grounded regardless of voltage. So here's a highlight, Figure 18, equipment grounding summary. So just read over all of these summaries. It says grounding for metal enclosures for service conductors and equipment. It's Article 250.80. The neutral conductor must be grounded on single-phase 3-wire systems. Connection of grounded service conductor to a grounding electrode. NEC section 250.24E. Connection of grounded conductors for non-current carrying metal parts. NEC section 250.142A. Connecting the equipment grounding conductor to a grounded conductor. Local codes a possible factor. It's, Article 250.24C basically says that the main bonding jumper is going to join the grounded conductor with the equipment grounding conductors and the grounding electrode conductor. That's, of course, the main bonding jumper. And the use of bonding jumper near points that may be disconnected, 250.68B. This is why we cannot use the water pipe as the sole means of ground. They've had plumbers come to disconnect a water meter, and when they pulled the pipe apart, they got electrocuted, literally, because all of the fault current on the panel was running to ground through the water pipe. And when they broke it, they became the ground. They're kneeling in the mud, and their hands are on the pipe. They pull it apart and break that connection, and then all of the fault current is going through them. So we have to put a jumper across the meter from pipe to pipe so that they can take the meter out without disconnecting the electrical continuity of this grounding electrode. But the water pipe cannot be the sole grounding electrode. That's why we have to have a supplemental ground rod when you have a cold water pipe as the grounding electrode. You have to have a supplemental grounding electrode. It says in all occupancies, major appliances, many handheld appliances and tools must be grounded. Appliances include refrigerators, freezers, air conditioners, clothes dryers, washing machines, dishwashing machines, sump pumps, and electrical aquarium equipment. Other tools likely to be used outdoors and in wet or damp locations must be grounded or have a system of double insulation. 3.1.0, the equipment grounding conductor. The equipment grounding conductor is used to interconnect and bond the non-current carrying metal parts of equipment, raceways, and other enclosures to the system grounded conductor or to the grounding electrode conductor, or both. 3.1.1, grounded and ungrounded systems. The equipment grounding conductor or path must extend from the farthest point of the circuit to the service equipment where it is connected to the grounded conductor. Figure 19 shows an equipment grounding conductor and its path to ground when a ground fault occurs. It's the path for ground faults within the system back to the source that completes the circuit, allowing enough current to flow to ensure the overcurrent device will trip. So here's a fault on this box, and because this is grounded, it allows enough current to flow to ground that will trip that circuit breaker. Here's a ground fault in an ungrounded system. This system is not normally grounded, but the secondary side of this 2-pole circuit breaker has the return, and it takes it to ground, so that if something happens, if something does occur, we have an equipment ground going to earth ground on the load side of the circuit breakers, so that if something happens, we'll have enough fault current flowing in order to trip this circuit breaker and disconnect it, even on an ungrounded system. Here's a highlight, sizing the equipment grounding conductor. It says the size of the equipment grounding conductor determined by using table 250.122 is based on the size of the overcurrent device that's protecting the system. not the ungrounded conductors like the grounding electrode conductor. For example, if the ampacity is 400 amps, the overcurrent device is set at 400 amps. Here's a highlight. Use NEC table 250.122 and go down the left-hand column until the desired ampacity or the next higher ampacity is found. For the 400 amp system, the size of the equipment grounding conductor is number 3 copper, or alternately a number 1 aluminum or copper-clad aluminum. Now determine the size of the equipment grounding conductor for a flexible metal conduit connection to a motor supplied with a 30 amp circuit using the following steps. So they'll do the same thing. They'll find the overcurrent protection device. It says this 30 amp circuit will have a 30 amp overcurrent protective device feeding the circuit. Find the 30 amp in table 250.122, a number 10 copper or number 8 aluminum or copper-clad aluminum equipment grounding conductor is required for the 30 amp circuit. So here's your flexible raceway, and you have size of the conduit does not exceed 1.25 inches. It's suitable for grounding with a maximum of 6 feet in ground return path and a maximum 20 amp overcurrent protection. The connectors must be listed for flex and grounding. When used to connect equipment where flexibility is required, an equipment grounding conductor must be installed internally. All right. So here's the same conduit, but instead of being flexible, this is installation requirements for liquid tight flexible metal conduit. It's still flexible, but it has liquid tight on the outside of it. And again, you have to have a ground internal. It's permitted in the earth where listed and marked, fitted listings, listed for grounding purposes, and it's acceptable for grounding if listed and meets the following conditions: the maximum 20 amp circuit, overcurrent protection for 3/8 to 1/2 inch, maximum 60 amp for 3/4 to 1.25 inches. Fittings are listed for grounding, and when used to connect equipment where flexibility is required, an equipment grounding conductor must be used. 3.2.0 Grounding and enclosure. As previously mentioned, equipment grounding covers the metallic non-current carrying parts of an electrical system. Such parts include metallic conduit, outlet boxes, enclosures, and frames on motors and other electrically operated equipment. These items are bonded together to ensure the proper operation of the overcurrent device in case of ground faults. A bare or green insulated equipment grounding conductor is usually attached to the metal frame or cabinet of the equipment. When connected to the circuit, the equipment grounding conductor is attached to the equipment grounding system that, in turn, was originally bonded to the system neutral bus bar at the service entrance equipment. When properly connected, if a live ungrounded wire should touch the frame or cabinet of a motor, appliance, or other metallic object in the system, a ground fault will occur and open the overcurrent protective device, that is protecting the circuit. Consequently, equipment grounding is one of the best methods of protecting life and property from a ground fault. Grounding outlet boxes and devices. Let's see here. I don't want to read this whole thing. So here, if you have a metallic box, you can put a grounding clip on the edge, the side of the ground of the edge of the box, and tie the grounding equipment ground to it. If you have non-metallic boxes, you'll take your equipment ground to the receptacle, or if it continues on through the other conduit, you'll put a wire nut and you'll make sure that all the equipment grounds are continuous and a pigtail goes to the receptacle. If it's a metallic box, you're going to ground the box as well as taking wires through the conduits and taking a pigtail to the receptacle. Or you can use the grounding clip on the edge of the metallic box. That's also fine. This one is using the conduit as the equipment ground. You have to check local codes because the National Electrical Code says we can use EMT, rigid conduit, and intermediate conduit as an equipment ground, but some local municipalities will say no. So be very careful about just grounding the receptacle, the green screw to the back of the box. That's using the raceway back to the panel as the equipment grounding conductor. If two or more cables enter the non-metallic box, each of the equipment grounding conductors must be connected to each other with an approved connector. Then one of the grounding conductors from the bundle must be attached to the grounding terminal on the receptacle itself. The ground terminal cannot contain more than one equipment grounding conductor. Types of equipment grounding conductors. Use a copper or other corrosion resistant conductor, solid or stranded, insulated, covered, or bare, and in the form of a wire or a bus bar of any shape. You can use rigid metal conduit, intermediate metal conduit, listed liquid type flexible metal conduit, electrical metallic tubing, listed flexible metal conduit and tubing as permitted by NEC section 250.118.5, 118.6, 118.7, armored cable, the copper sheath of mineral insulated metal sheath cable, metallic sheath of the combined metallic sheath and grounding conductors of type MC cable or cable tray as permitted in NEC section 392.60A and 60B. Again, check with local codes. The municipality may not allow you to use rigid, intermediate, or EMT as an equipment grounding conductor. Cable bus framework is permitted in NEC section 370.60. Other electrically continuous metal raceways listed for grounding. So here's a jumper across the seam of cable tray. They have a splice plate, but you can't rely on the splice plate for grounding. So you put a jumper across the seam, the connection of the cable tray. And you can use cable tray as an equipment grounding conductor. Section 3 review. The equipment grounding conductor of a flexible metal conduit connection to a motor supplied with a 20 amp circuit is, then you can go and check and see what the size would be. When using non-metallic boxes for receptacles with type NM cable, the equipment grounding conductor, and then you can look that up. We're just looking at that. All right, let's sprint ahead. We'll go on to the next section. I'm not even going to stop the video, I don't think. I'll just keep going. 4.0.0 bonding service equipment. Explain how to bond service equipment. Explain how to size the main bonding jumper. That's 251.02. Describe the bonding of multiple service disconnects and explain how to bond enclosures and equipment. Electrical continuity is the key to successful clearing of ground fault currents. This continuity between service equipment and enclosures is maintained by bonding. The items that are required to be bonded together are listed in NEC section 250.92A. They include the following items: service raceways, cable trays, cable bus framework, or service cable armor or sheath. All service equipment enclosures containing service conductors, including metal fittings, boxes, etc., interposed with the service raceway or armor. Bonding equipment to the grounded service conductor in a manner provided for in NEC section 250.8. Oh, I'm sorry, here it says that NEC section 250.92B defines the methods permitted to be used to ensure continuity at service equipment, and they include bonding equipment to the grounded service conductor in a manner provided for in section 250.8A. Connections utilizing threaded couplings or listed threaded hubs on enclosures if made up wrench tight. Threadless couplings and connectors if made up wrench tight. Other approved devices such as bonding type lock nuts. The exception to this requirement is found in NEC section 250.84A. It states that an underground service cable that is connected to the grounded system conductor or the supply side is not required to be connected to the grounded conductor at the building or structure. Main bonding jumper. When a listed switchboard or panel board is installed, the main bonding jumper provides the equipment, provided with the equipment is rated for the size of the conductors used for the service. Main bonding jumper is a connection made between the grounded circuit conductor and either the equipment grounding conductor, supply side bonding jumper, or both of these at the service. Here's a highlight. It says, since the main bonding jumper must carry the full ground fault current of the system back to the grounded service conductor, its size is related to the rating of the service conductors. NEC table 250.102C1 is used to determine the size of the main bonding jumper. And it goes by the size of the ungrounded conductors. Figure 24 shows how to calculate the size of the main bonding jumper when parallel runs are used. So, calculating the main bonding jumper for parallel runs. You've got parallel runs. You're going to take 4 250 kc mil aluminum conductors. That is a total of 1,000 kc mil. So you use table 250-102C1, you go down to 1,000 kcmil, and you find it's a number 2-aught copper or 4-aught aluminum. So each one of these parallel runs has to have a 2-aught copper in it. Each equipment grounding conductor in this conduit has to be able to carry the total fault current, not just the fault current of this parallel run, but the total fault current of the entire system. So you have to size it according to the 1,000 kcmil, and then that's the size of the bonding jumper that you use inside these raceways. Where the multiple conductors are larger than the maximum given in table 250-102C1, the jumper cannot be less than 12.5% of the area at the largest phase conductor per the first note under table 250-102C1. An example of three 500 kcmil copper conductors gives a total area of 1,500 kcmil. Because this is larger than that of NEC table 250-102C1, take 12.5% of the total area. This is 187.5 kcmil. Since this measurement doesn't represent a standard size conductor, refer to Chapter 9, Table 8, Conductor Properties, and go to the next size. The table shows that the next larger conductor size in circular mills is 211,600. It's a size 4-aught. So that's what you'd use for your bonding conductors. Bonding multiple services. Multiple disconnecting means can take several forms. NEC Article 230 Part 6 discusses the various forms. Because this bonding jumper is located on the supply side of the service disconnect, the basic rule for sizing the supply side bonding jumper to bond these various configurations is found in NEC section 250-102C. This section requires the use of table 250-102C1 for selecting the size. The supply side bonding jumper is a conductor that ensures the required electrical conductivity between metal parts that must be electrically connected. Typically installed on the supply side of the service or within the surface equipment enclosures or for separately derived systems. All right. It says, however, if the size of the service conductor is larger than 1,100 kcmil copper or 1,750 kcmil aluminum, the bonding jumper must have a cross-sectional area of not less than 12.5% of the largest phase conductor. So here's a highlight. They're talking about the surface entrance conductors and what size bonding jumper. For a 3-aught ungrounded conductor, you need a number 4 gauge bonding jumper. All right. 4.3.0 bonding enclosures and equipment. The bonding requirements for an installation depend on the system voltage, the number of raceways, and the type of equipment in use. So bonding services over 250 volts. NEC section 250.97 defines the method permitted to be used on circuits over 250 volts. The methods permitted for these circuits are the same as for services, with the exception of using the service grounded conductors. Examples of these bonding methods are shown in figure 25. So you can use a threaded hub. You can use a fitting that seats firmly against the enclosure, or one lock nut inside the enclosure. Typical enclosures with circuit conductors over 250 volts. There's a bonding jumper around the concentric or eccentric knockouts. If you're using knockouts that are factory installed, eccentric or concentric, you have to put a meg bushing on your conduit nipple and take it to the grounding bus. Here's bonding type lock nut, full metal contact double lock nut. Bonding multiple raceway systems. NEC section 250.102D allows the use of a single conductor to bond 2 or more raceways or cables where the bonding jumper is sized in accordance with table 250.122 for the largest overcurrent device supplying those circuits. Figure 26 shows bonding of multiple raceways. So you can put these meg bushings or bonding bushings on the conduit, and you can just jumper from one to the other and then take it to the equipment grounding bus. And these are all considered bonded. Individual bonding jumpers, you could just bring individual bonding jumpers to each meg bushing. 4.3.3, installing the equipment bonding jumper. The equipment bonding jumper is permitted to be installed either inside or outside of a raceway or enclosure. When the jumper is installed outside, the length is limited to 6 feet. The bonding jumper must also follow the raceway routing. This is vital to keeping the impedance of the equipment bonding jumper as low as possible. Figure 28 shows a bonding jumper installed inside a non-metallic enclosure. So here's a bonding jumper inside a non-metallic enclosure. It goes from one meg bushing on a metal pipe to another meg bushing on a metal pipe. So, creating an effective grounding path. Remember, for both grounded and ungrounded systems to be successfully grounded, there must be a permanent and continuous effective ground fault path. It's an intentionally constructed permanent low impedance electrical conductive path designed to carry ground fault current from the point of ground fault to the electrical supply source. This facilitates the operation of the overcurrent protection device or ground fault detectors on a high impedance grounded system. The path must be sized to safely conduct any fault current that's likely to occur, and the path's impedance must be low enough to limit the voltage to ground and to facilitate the operation of the circuit overcurrent protection device. Low impedance in this case means that the grounding path and the circuit conductors must always be within the same raceway, or the raceway itself may provide the grounding path. A grounded conductor or neutral in a grounded system serves two main purposes. It permits utilization of power at line to neutral voltages. This will allow the current carrying conductors to carry any unbalanced current, and it also provides low impedance return path for the flow of fault current to the source to facilitate the operation of the overcurrent devices in the circuit. So, figure 29 shows the return path for this ground fault current that includes the grounded conductor back to the source. So, here is the line side of a or the load side of a transformer feeding a panel. This is the main circuit breaker to the panel. And here is the ground from the center tap of this secondary of this transformer going to ground. Then we have the low impedance path. That's the neutral going to the neutral bar. And then this is also grounded. The neutral bar is also grounded. So this gives us a low impedance path. Actually, they're saying it's going through the earth. So it's a high resistance, high impedance path for this fault current. That's not good. What we want is a low impedance path. So that's what this one is. This is the low impedance path, this neutral going back to the load side transformer coil. That's the path that the fault current is going to take. It's not going to go through the earth. It's going to follow this neutral back to the transformer. Section 4 review. Main bonding jumper for 3/0 service conductors. I'll let you look that up. If you're bonding multiple disconnects and the size of the service conductor is 1,000 kcmil and a wire away, the size of the bonding jumper is, I'll let you look that up. And also, when an equipment bonding jumper is installed outside of a raceway, the length is limited to how many feet? All right. Well, we'll go on to the next video. I'll meet you there.